And I'm not sure what happened to OneNote. There we go. We're fine. Shh. No, thank you. Wouldn't eat that if you, paid me. Shh. So today we're doing, it's section 6.3 again, but this is part 2, which is the Disck method. So we did 6.3 yesterday, volume by known cross sections. Today we're doing volume of revolution. So it's section 6.3, volume of revolution, but we're doing the Disck method. Volume of revolution, Disck method. Yes, Disck method. All right, so what is going on here is that we are revolving something around an axis of rotation. So suppose that this is the y-axis and this is the x-axis, and I'm going to draw some curve that looks like this. That's my region. I'm going to take that region and I'm going to revolve it around the y-axis, and I'm going to produce something. So if this is a radius right here, that's some radius r. When you revolve it around that axis, are you going to produce a circle? Now, it's going to have, see right here, that is some delta y. So is that going to be a disc, a cylinder? So I'm going to draw it off to the side. There's my radius. I'm going to go all the way around, and it's going to have some width that's delta y. Is that going to produce a cylinder, a really, 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 really flat cylinder like a disc? Yeah? Okay. If I do a bunch of those and stack them, will I produce a solid? All right, so I'm going to draw this kind of. So what's happening is I've got this base. Oh, that's a little bit too crazy. My base goes to here. Looks like a Hershey Kiss to me. But I smell chocolate right now, so that's going to be the case. Okay, so do you have in here? Do you have this whole region in here is being revolved, right? This whole thing. That's the region. If I take that whole region and revolve it around and sweep it around, do I produce a shape that looks like a Hershey Kiss? Yeah. Okay. So I'm going to plane. Hopefully we picked up right where we left off. It doesn't seem, yeah, it's timing. Okay, here we go. All right, so the whole point here is when we look at this, this R, from what we did with areas, is this region, because I'm revolving this way, this dimension right here, is that going to be a right minus left kind of dimension? Yeah. That R, that representative R, hang on, let me get rid of that. That representative R is going to be the right curve minus the left curve. In this case, is the left curve the axis rotation, wherever it is. And we're going to start off today where it's just the y-axis, but eventually am I going to move it, like on the demonstration, am I going to move it off? It's just a vertical line somewhere, or it can be a horizontal line somewhere, right? And if we look at this disc, so that's my delta y, this is my r, and it's going to be in terms of y. Do you see that? If I'm doing right minus left, does that mean in terms of y? So what this is saying is if your axis of rotation is the y-axis or is parallel to the y-axis, which means my region or my radii, are they perpendicular to the y-axis? Whatever that radius is perpendicular to, that's going to be what it's in terms of. So this is in terms of y. So if I look at this disk, do we all agree that the area of that circle is pi big R squared? Agreed? And y, and r is in terms of y. Does that mean the volume of each disk? So that's for the first one. And is the volume of just that one disk pi r 1 squared delta y? What happens if I do an infinite number of these? It's an integral. So what we're going to do is, back to limits, we're going to do the limits. As the number of those stacked disks goes to infinity, that looks like an 8, infinity, of summation of I equals 1 to n of pi, the r sub I squared, delta y. Is that an integral? Now, let's look at this. If I'm stacking these disks, am I going from, suppose this is y equals 0, am I going from here to whatever y is b? Is this what I'm integrating? Am I integrating this? Am I stacking disks like that? Are those my limits of integration? So it's all in terms of y. So this means this is the integral from of y of a to a y of b. Those are y values. That's y2, that's y1, of pi r, don't worry about the i's, squared, dy. Is it just cylinders? And if you've done the area worksheet and you practice right minus left, and you did the volume by known cross-section and you practiced right minus left, is the same way to find the dimension. Because I remember I said that there's this dimension L, some length, right, when we were doing area. And then it still was a length, but it became a diameter or some other length on an area for a not volume unknown cross-section. For volume of revolution, that length is now a radius. It's the radius for my revolution. And I'm going to produce a solid. Well, if I could do it on the y-axis, can I do it on the x-axis too? Of course I can. So this time, we're going to, whoops, that's really ugly. We're going to revolve around the x-axis. I have yet another, I'm going to pick another color. I want a different color. Where's that? I want brown. Brown for chocolate. Oh, look. I got this. Oh, there's my region now. And I'm going to revolve it around the x-axis. So are these all my cross sections? So what's going to happen is I'm going to produce a Hershey Kiss that's laying on its side. And is that the radius that I'm revolving? So now that I'm revolving around the x-axis, I want everything in terms of x. Instead of doing right minus left, what am I going to do? I mean, top minus bottom, upper minus lower. Shh. Upper minus lower. All right. Are my limits of integration now in terms of x? Yeah, so this is going to be my A, this is going to be my B. Do you see that if we just take a typical cross section, I want y'all to draw this, by the way. See what that one? I want to draw that one right there. I'm going to draw it right down here. That's the radius, right? Is there going to be another one down here? Yes. Okay. You can just watch me if you want, but eventually you're going to have to do it. Is that the cross-sectional area of this thing right there? This is big R. And does this thing have delta x this way? If you look on the end, is that a delta x, a thickness of your disk of delta x? If I do an infinite number of these, is the delta x going to 0, and instead of stacking a bunch of disks, I am essentially coloring it in with circles. I'm stacking circles, right? An infinite number of them, is that going to give me the exact solid? So now, we got limit. As the number of disks goes to infinity, summation of I equals 1 to n. And what is the cross-sectional area of this thing? Pi r squared. But now instead of delta y, it's delta x. Does that mean I'm going to integrate from A to B? Can I pull the pi all the way out in front? It's just a coefficient, right? Pi r squared dx. You can. So, if your axis of rotation is the x-axis, if your radii are perpendicular to the x-axis, this is all going to be in terms of, yes. So when they give you the words behind all this, by the way, here, I'm going to make this even more obvious. This is in terms of x, right? The radius is in terms of x now. Let's make this really easy to tell. Up there on our y one, That was a radius in terms of y, all that squared. Right? Everything's in terms of y or everything's in terms of x. Do not mix and match. Capiche? Kaposh. Awesome. So we're about to do a problem. Let's see if we have enough room. We have enough room to start this. All right, so our example. Example 1. We are going to find the volume. Shh. Y'all are very chatty today. Find V. Can I just abbreviate so we can get on with this?
Sure.
Okay. Okay. And then what is it? We have a region defined. That's a really ugly G. You know how you've been doing those area problems? Well, are they the same regions? Do I define them the same way? And then we're going to revolve them. So it's defined by y equals 4 minus x squared. X equals 0 and y equals 0 in the first quadrant. Am I going to tell you that so I make sure you don't get all kooky and go do more than you need to? In the first quadrant. And you're going to take that region and you're going to revolve it around the x-axis. Oops. We're going to find the volume for a region defined by y equal 4 minus x squared. X equals 0, y equals 0 in the first quadrant, and we'll revolve it around the x-axis. If I'm revolving around the x-axis, what's it in terms of? What? Oh my Lord. Y'all need to keep this. Okay, there's revolving, which makes it easier, but the other ones, like for the area, it was what it was perpendicular to. Remember that? Now they make it really easy. Whatever, if you're revolving it around the x or y axis, that's telling you what it's in terms of. We'll get on to the other ones later. Okay, let's sketch this thing. Does everybody have the problem written down? All you need to write down is region is y equal 4 minus x squared, x equals 0, y equals 0 in first quadrant, and x-axis is the axis of rotation. Let's sketch this. We're going to sketch it and then we'll do the work on the other page. So I know what this looks like. I know what this looks like. That's a parabola. And my parabola, because y'all are infected. My parabola is going to start at 4, and it's going to aim down, right? Because I know it's negative, so I know that it's going to go down 1, and then for 2 it's going to go down 4. Is it going to be that region? This region right here, yes? Wow. So this equation right here, and we only want the first quadrant, so I'm not drawing anymore. This is that's my function. F of x is equal to 4 minus y, x squared. Sorry, x squared. Yes? Right? This is x equals 0. This is y equals 0. So is that my region? I'm going to revolve it around the x-axis. Does that mean all of my cross-sections are perpendicular to it? So if I'm going to do this, those are my radii. So we're going to pick one right here. This is going to be our representative one. That's big R. Draw it over here. Here's a sketch. There's big R. Maybe. There's big R. I'm going to run out of room down here, but pretend it went all the way down. Is it going to produce a disc? And what's the thickness I'm looking at? That's a delta x. This R is in terms of x. Do you see it? It's got to be in terms of x. So what does it equal? What does my R equal? What's the upper curve? 4 minus x squared minus, what's the lower? 0. Am I making you write that for a reason? Because what am I going to do? I'm going to take this whole thing and shift it up or shift it down. And are you going to be subtracting from something besides 0? So I want you to write the 0 for now, because later, when I shift that, you're going to go, this is easy. I just have to subtract 2 or whatever it is you shifted the axis to. Got it? Of rotation. So right now, write the 0. We have r in terms of x. What else do we need in terms of x?
The A and B.
Limits of integration. So when I'm stacking my disks, what's my A going to equal? What's it start at?
0.
What is my B going to go to? 2. Is that too easy? I think it's too easy. No, that's not too easy. Is it nice to have easy? Oh, y'all should try it more often. All right. So I'm going to turn the page. I'm going to write the equation. Everybody ready? Is it going to be volume is equal to pi, because I can factor the pi all the way out, right? Integral. What were my a and b's again? 0 to 2 of, what was my r? 4 minus x squared dx. Okay, now what? Okay, do not do u sub on this. There's nothing outside. Do you just have to do a little algebra first? What's 4 squared? 16. Okay, that's going to produce the 4 times the negative x is going to be a negative 4x squared, but there's going to be 2 of them, so it's minus 8x squared. Did you see what I did? And then what's negative x squared times negative x squared plus x to the 4th dx. Once you do that one little algebra 1 step, is this easy? Okay, we've done the hard part. The calculus is easy. The algebra was shouldn't have been hard. And then the geometry before that shouldn't have been hard. Put it all together, it's hard. Until you get the hang of it. All right, what's the antiderivative of 16? What's the antiderivative of negative 8x squared? And then what's the antiderivative of x to the 4th? Evaluate from 0 to 2. Is this going to be easy to evaluate? Can you play 2048? This is 2048 because we're doing twosies. What's 16 times 2? 32. Okay, what's 2 cubed? What's 8 times 8? What is 2 to the 5th? Wait, 2048. 2, 4, 8, 16, 32. Minus the 0. Check it, though. Putting a 0 here, putting a 0 here, putting a 0 here. It's 0, right? Check it, especially when it's trig. Because cosine of 0 is not 0. Oh, putting it all together. Now, if this was on my test, you would stop right here if you didn't have a calculator. But if you're just dying to, it's 256, because I could play 2048. 15 pi, that is my volume. Wow. Wasn't that bad, was it? But are there a lot of steps in there to trip on? I'm watching y'all go up the stairs and you're catching your toe on every single step and stumbling. Got pick up your feet. Y'all are dragging your feet. Shh. Shh. Would you like to see one that's with respect to y? You probably need to. So maybe I should calm down. I don't know. Is it because it rained? Is it because there's another? I don't know. I don't know. The phases of the moon are not right. Y'all are just crazy. Okay, here we go. Shh. Shh. Now. Shh. Shh. We are going to revolve a region. I'm going to define it below around the y-axis now. If it's around the y-axis, what's that with respect to? So with respect to y. The region is defined, and I can just do this. I can do region, and you just have to realize that it is yx to the 2/3 power. Yes, we do fractional powers. Oh, x, wait, hang on. I didn't do an equal sign. Y equals, that's better. X equals 0 and y equal 1. Really, really, between those three things. And y'all have no idea what this looks like. It's okay, I know what it looks like. I'll help you. But there's a problem. I can sketch it. I can do all this, but before we start, it would be really nice to know points of intersection, wouldn't it? Okay, I'm going to make it really easy for you. Put an x of 0 in. What's y? Put a y of 1 in. What's x have to be? 1. Did I give you your points of intersection? Oh, just look at these and use them. It was that simple. All right, so I know my points of intersection are 0, 0, and 1, 1. So we're going to just sketch it. This is going to be a swag it in kind of thing, okay?
Swag.
Swag. Here's swag.
Sound like Connor.
By the way, this is x equals 0. Yeah? Let's draw in y equal 1. Oh, let me do a different color. Here's y equal 1. I'm just going to put it here. I can pick it anywhere I want. Hang on, it's not very good. There we go. This is y equal 1. And then I know that 0, 0, and 1, 1 are points of intersection. I know what this looks like. And all you really need is the curvature. Could you take the derivative of that and see if it's concave up or concave down? Could you use your calculus skills that you from prior units to figure out the kind of shape of this thing? Let me show you what I'm talking about. For that function right there, what is the derivative with respect to x of x to the 2/3 power? It's 2/3 x to the negative 1/3, right? Okay, so you know it's increasing, yes? Could you take the derivative of that? Take the second derivative. 2/3 x to the negative 1. I just need to know sign. Is that going to be greater than 0 or less than 0? Is it less than 0? Because it's going to be negative 2/9 x to the negative 4/3. So I know because the first derivative is positive, it's increasing. I know for the second derivative is negative, it's going to be concave down. Do you remember that stuff? Oh, you're going to have to. So what does my curve look like? I don't even really care what it really is, but does it look like that? I know that it's increasing because the first derivative is positive. I know it's concave down because my second derivative is negative. And oh, look what y'all are supposed to be able to do now. Y'all can't, anything you've learned in here, you're supposed to be able to still do.
What the heck?
All right, we are revolving around the y-axis this time. This one, does that mean my radii are perpendicular to my axis of rotation? Right in here, am I shading the region I'm revolving? Between y equal 1, x equals 0, and y equal x to the 2/3 power. But I said that if it's a y-axis rotation, then I have to have it in terms of y. Is this equation in terms of y? No. So what do? So we've got y equals to x to the 2/3 power. How do you undo that? You multiply by the reciprocal. You raise it to the reciprocal power, right? 3/2. So what does x equal for this? When we get it into the terms of y, x is equal to y to the 3/2 power. Do you see it? Yeah. So if I'm talking about one radii, this one right here, I'm going to go down here. I'm just going to sketch it. What does it look like? Is that my radius? And am I going to produce a circle, but it has thickness? If I look this way, is that a delta y? What is my r? What's y to the 3/2 power minus what? 0. Because it's this one minus this one. Yes? Does everybody see that it's right minus left? If you have practiced your area worksheet, does it help with this kind of stuff? The whole point of the area and the volume by no cross-section is that by the time we get to the disc and we have to move stuff, hopefully y'all know what y'all are moving. If you haven't done the area and volume by no cross-section, do you need to go do those? Because this is going to be next to impossible if you can't identify the regions, right? You understand what I'm saying? Okay, we know it's a disc. We know that it's in terms of y. What are my limits of integration? What am I starting at? Y equals 0. Is that my first limit of integration? What am I going to? Was this one really easy because they kind of gave it away? Oops, that's a 1. They kind of gave it away, didn't they? This didn't look like a really easy problem, but is it? Oh, yeah. Okay, let's set this up. My volume is equal to pi. What are my limits of integration? 0 to 1 of y to the 3/2 power. Watch the magic. I'm going to square it. That hot mess, awful thing is going to be so easy now. Do you see how magical that was? Y'all were all dreading that fractional power, and I just made it go away. Isn't that magical? Now you're going to get a fractional answer, but that's okay. What's the antiderivative of y cubed? Y to the 4th over 4. I'm evaluating from 0 to 1. Does it get any easier than this? No. I'm not going to make it any easier than this. This is ridiculously easy. So is it 1/4 minus 0? So my answer is pi over 4. See? Oui? I don't know what language that is. Okay, so your mission, and you don't get a choice on this. You don't get to reject it. If you reject the mission, it's going to blow up your grade. Sounds like a personal problem. Not my problem anymore. It's y'all's problem.